Hello everyone, and welcome to the videos for the Cumulative Review Packet number 14. The first questions here are all about graphing, and we need to make sure we remember what general shape these are before we begin. So if I take a look at number 1, and notice that the function is squared. So this is either going to be a parabola facing upwards or a parabola facing down. Because I see the negative down here, I know it's going to be a parabola or a U-shape facing downwards. In terms of shifts, I'm going to go down here. If I see x minus 2 in the parentheses, this is always opposite of what you think. So this parabola is going to move right 2 units. The minus 6 on the outside means we're going to be moving down 6 units. And the negative in front means you're flipping or reflecting over the x-axis. So the first thing we want to do is start at 0, 0, because that's where the parent function, meaning just plain old x squared, we are moving from x squared specifically, and we're moving right 2 down 6, and so my vertex would start here. Then, because it's a parabola always has the same pattern. From the vertex, we always go over 1 down 1, over 1 down 1, over 2 down 4, over 2 down 4. So from here, I'd go over 1 down 1, over 1 down 1, from the vertex over 1, 2, down 1, 2, 3, 4, over 2, down 1, 2, 3, 4. If this was a parabola facing upwards, you would do the same pattern except go up instead of down. So your general shape would look like this in blue. Now that I have my picture, my domain, remember, is always from left to right. So my domain, this graph is going to go all the way towards negative infinity, all the way towards positive infinity. So my domain is negative to positive infinity with parentheses. My range is bottom to top. So if I start down here at the bottom, I'm starting down at negative infinity. And then my graph is going up to the very top point, and that y value is negative 6 with a bracket because it is included or can be touched on the graph. Number 2 is done the same way, except because I have absolute value signs, that means that my shape is going to be a V. Because I do not see a negative in front, it's going to be a right side up V. So if I think about shifting, and again, I apologize for this Smart Notebook limited mode. Again, right now our Smartboard software needs to be updated. So there that is. Anywho, describe the shifts. I'll bring it down here. We are moving, inside is the opposite. So we're moving left 3 units. And then we are going up 5 units. There is no flipping around the x-axis this time. So I would start from 0, 0, left 3, up 5. That would be my vertex. And then because my shape is a V, my pattern from the vertex is over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1. So from here, over 1, up 1, and we make nice straight lines. So my shape would look like this. And now that I have that graphed, my domain, like the parabola, is going forever towards negative infinity, forever towards positive infinity. And because I'm going left to right, negative infinity comes first, then I'm going to positive infinity. My range is going to be somewhat the opposite of the previous problem, because my lowest point this time is down here at 5 with a bracket, because it's actually on the graph, and then my graph goes up towards infinity. So again, range is really bottom to top. So we want to shift using parabolas, we want to shift using absolute value graphs, and thirdly, and taught the most recently, we want to shift radical graphs. And you might remember in class I said that a radical graph, or the square root graph, is the inverse of something like number 1. So number 1 was a parabola, and so what we did in class was we took a parabola and we put it on its side, but then we talked about that a parabola is not a function if both pieces are here because it does not pass the vertical line test. So what we did was we erased part of the graph, so my graph would either look like this in red, so this would be a picture of a square root function, or it would be this piece going down, dependent on if there's a negative in front. So before we do that, I want to talk about the shifts. If I see x minus 1, this means that I'm really moving right 1 unit from 0, 0. And if I see plus 3, I'm really going up 3 units. So I'll go over there, write 1 up 3. Here's my starting point. Because there is no negative in front, I know that my graph is going to look like this. And we are a little bit getting used to this pattern still, so I want to remind you where that came from. I'm going to plug perfect squares into y equals the square root of x. Square root of x is the most basic parent function for the square root function. And I'm going to pick only perfect squares, 0, 1, 4, and 9. And if I plug 0 under a square root, I get 0. Plug 1 under a square root, I get 1. Square root of 4 is 2, and square root of 9 is 3. So from this point, I would use these 3 patterns. I would go right 1, up 1, right 1, 2, 3, 4 from the red dot, up 1, 2, then from the red dot, 1, 2, 3, 4, 5, 6, 7, 8, 9, up 1, 2, 3. So my graph looks like half of a parabola on its side. If I'm going to domain and range, the domain of my function for the first time is not negative to positive infinity. Because if I go from left to right, my pen first hits the x value of 1, so I'd start at 1, and then my graph goes all the way towards positive infinity. If I want to talk about my range, bottom to top, if I start down here, the first y value that my pen hits is 3, and then it also goes up towards positive infinity. Number 4 is also a square root function, except I have a negative in front this time. So if I'm talking about shifting, again, I'm going to come down here to avoid this. It looks like I have x plus 2, so that really means I'm going to the left 2 units. I am going down 1 unit. And lastly, because of the negative, I am reflecting or flipping over the x-axis, or flipping, okay? So I would start with the shifts. I'd start left 2, down 1, so here's my starting point. We are still going to be using the same values because it is still a square root function. However, because I know it's going to be facing downward, I'm going to go over 1, down 1 this time, over 1, 2, 3, 4, down 1, 2, and over 1, 2, 3, 4, 5, 6, 7, 8, 9, down 1, 2, 3, connect, and it looks like the bottom half of my parabola this time. So now if I look at domain, if I'm thinking again left to right, the first x value that I hit where this graph starts is negative 2. Then it goes on the number line towards positive infinity. My range, however, bottom to top, starts down here at negative infinity, and then the top y value that I hit is negative 1. Number 5 is a piecewise function, and so we want to draw 2 tables to figure out where it's starting and where it's stopping. So if I look at my first piece, the graph exists. The line of negative 3x plus 4 exists. I know it's a line because it's x to the first, if x is greater than 1. So in blue here, I'm going to start my table at 1, and values that are greater than 1 would be 2, 3, and 4, let's say. So I'm going to take all these values and plug them in to negative 3x plus 4, or negative 3 times 1 plus 4, negative 3 times 2 plus 4, negative 3 times 3 plus 4, and then if you want to, negative 3 times 4 plus 4. So those output values would be 1, negative 2, negative 5, and negative 8. And so if I were going to graph this line, I would start at 1, go up to 1. Because it's just greater than, not greater than or equal to, I would put a dot there. Every other point, though, is going to be a filled-in dot because the graph exists everywhere except 1. So if I graph the rest of my points, 2, negative 2, 3, negative 5, and then 4, negative 8, looks like I make a nice straight line that starts at 1 and then goes bigger than 1. So as the x values increase, my graph exists. So that's part 1. Part 2 is graphing this x squared function, so I know it's going to be a parabola before I start. I again am going to put 1 at the beginning of my table because I want to include it, but this time this graph only exists if x is less than or equal to 1. So I'm going to pick numbers less than 1. Let's start with those. I'm going to plug all of those values into 2x squared plus 1, and please make sure that you are following the order of operations when you do so. Let me plug in everything first. Make sure you square the 1 first, so that's 1 times 2. 2 plus 1 is 3. 0 squared is 0. 0 times 2 is 0, plus 1 is 1. Negative 1 squared is positive 1, times 2 is 2, plus 1 is back to 3. Negative 2 squared is 4. 4 times 2 is 8. 8 plus 1 is 9. So these are my values for the x squared function. So the first thing I would graph is 1, 3. But this time, because it's less than or equal to, I would have a closed dot here at 1, 3. Next, I want to graph 0, 1, which is pretty close to this graph. Negative 1, 3. And then negative 2, 9. I know that this is supposed to be a parabola, so I'm going to start at the first dot, continue my graph this direction, so it looks like a portion of a parabola, which makes sense for a piecewise function. Now that I have my graph, I can answer these questions. Remember, f of 1 means when my x value is 1, what is my y value? So I look over at my graph, I'd go over to 1, look up at the graph, and I have two possibilities, a hole and a closed dot. Between the two, this is the value that actually exists. So the y value that goes with 1 is positive 3. f of 4, if I go over to 4 and down, the y value that goes with my x value of 4 is negative 8. f of 10, however, is not on the graph that we have right now. If we kept drawing it, it would be. So what you could do is look back at the original function and say that 10 has to be part of one of these two intervals. Is 10 bigger than 1, or is 10 less than or equal to 1? Well, it's bigger than 1, which means if I want to find the y value that goes with this x value of 10, I'm going to take 10 and plug it into the function of 3x plus 4. So negative 3 times 10 plus 4, negative 30 plus 4, or negative 26. So whenever in a piecewise function you do not see something on your graph, remember that these functions only exist at certain places, and think about where this number fits in up here. Last but not least, f of negative 1 minus f of 4. f of negative 1, the y value that goes with negative 1 is here at 3 minus f of 4 is here at negative 8, and I already asked you that here. So that would be 3 minus negative 8, which is really negative 3 plus 8, or 11. On to some radicals. Number 6 is asking you to add some radicals. And when you add, you can only combine like terms if the radicand is the same. Now the number in front of this root 5 is a 1. So these two are like terms. So I have 1 root 5 plus 3 root 5s. So I have 4 root 5s minus 2 root 7. Are these like terms? No, I can't add or subtract them because the radicand is not the same. So my final answer for 6 is just 4 root 5 minus 2 root 7. Number 7, remember anytime you see something that is squared, I would consider writing it twice. So it's really 3 root 5 times itself. Now, there's no plus or minus signs here, so it's not FOIL, but I do see some like things I can multiply. 3 times 3 gives me 9. Root 5 times root 5 gives me root 25. Root 25 is really just 5 times 9. So my final answer is just 45. Number 8, we have this 5 multiplying in front, but this radical can be split into perfect and non-perfect piles. So if I look at 60, the biggest perfect square that goes into 60 is 4 times 15. X to the 6th is perfect because the exponent is even. Y to the 7th is not perfect, but I could split that into y to the 6th and then y. Z is also not perfect because the exponent's odd, but I can make this z to the 8th and then z. So if I simplify this piece, I have 5 in front still. Square root of 4 is 2. Square root of x to the 6th is 3. And then y to the 3rd, z to the 4th, root 15yz. Multiply those. My final answer is 10, x to the 3rd, y to the 3rd, z to the 4th, root 15yz.